How many of you have ever heard that manufacturer's best fit is not giving the same outcome as the NAL, NL2 targets or the DSL-IO targets? How many of you ever heard that? Okay, well, for those of you who haven't, let me be the first to tell you there's ample evidence that the two are not the same. And really, when you think about it, they never really can be the same. Let's assume that tomorrow the manufacturers come to some insight that allows them to make the best possible manufacturer's first fit. Some of the things they don't know is going to make problems for them. For example, they don't know how much air volume is trapped beyond the tip of the ear mold or the earpiece, whatever it may be, and the eardrum. They don't know the extent to which the pinna deviates away from the head. They don't know the depth of the concha and its size. They don't know how much hair you have in front of your ear. And you think, well, and even down to the clothing you're wearing, how much absorptive clothing are you wearing? And you might think, well, those results can't be that meaningful, but back in the 70s and 80s, when they were developing the Knowles electronics mannequin for acoustic research, Sachs and Burkhardt looked extensively at that question, and they found that, wow, we better really take into account all these individual variations because it really changes our output as measured at the eardrum or at the microphone of Keymark. So even under the best of situations, with the best of manufacturer's fittings, we can't really be sure we've closed all the gaps in audibility. And if you look at the literature, it looks even less promising. For example, the first study here was ours, so I can speak about it without having to look too much. If you look at the zero line, which is, do we have a pointer? No. Yes, we do. I got a finger. If you look at the zero line, that means from these 6 manufacturers' premier hearing instruments with the manufacturer's best fit put into them based on the user's history, sex, date of birth, you name it, it's all in there. This is how well they could do. And to help you interpret this, whenever there's a deviation below the zero line, it means it was too weak. And when there's a deviation above the line, it means, oh, wow, you found one. So there is one.
Red line.
Oh, fine. And when there's a deviation above, that insinuates that, of course, they had too much gain, which is curious for these patients because they all had symmetrical hearing losses. So it's really hard to explain why are these two graphs for the right and left ears different? Why aren't they exactly the same? The air should be the same. Well, again, the air volume beyond the tip of the ear mold, all the things we discovered are different, even on the same patients. So you're not going to expect to see exactly the same gain reserves. And in the worst, back up one, in the worst instances, you can see they're down by 10 dB in a whole bunch of places, and some critical regions important for understanding of voice consonants, for example. So already you're starting to see that, well, maybe that manufacturer's best fit should be called something other than best. The next slide talks about the data from McCurry, Bentler, and Rausch, where they looked to see how close these hearing aid fittings came to their target. And again, you can see the average line there. They didn't hit it very often. They're all over the place. And in fact, they found that 55% of those hearing aids fit did not conform to those targets using a plus or minus 5 dB or a 5 dB RMS error rating. So 2 studies now saying adults and children are not getting very good hearing aid fittings. The next one is from Dr. Amlani and his colleagues, where he showed that the aided speech intelligibility index, the audibility of speech, was 10 to 16 percentage points lower with the manufacturer's best fit. Again, insufficient gain. This is sort of a recurring theme. If you look at the international studies, it's even more depressing. 73% of their patients miss that 5 dB RMS error. And finally, if you look at the Canadian data, only 10% were off, but something about the Canadian data, the people that were looking at it were the people that developed the DSL-IO, so you can expect that their users are all getting the best real ear DSL-IO fitting they can. So that's like the best case scenario, only 10% error. All right, next slide. And then, because I just didn't have room to put it all on one slide, if you look at the work of Valente and his colleagues at Washington University Medical School, now they're looking at outcomes. They said, well, you know, phoneme audibility, speech, individual word audibility, and sentence audibility, both quiet and noise, are suffering because of this manufacturer's best fit. It's always better when you're using real ear aided verification of target. And the part that impressed me is even their patients, when they went out with these hearing aids and completed the AFAB reverberation and adverse listening situation subcategory, said, yeah, we noticed that we're not hearing as well with these best fits as we do as when you fill in the gaps, essentially. And same with data. Next. You must have one too. Oh, you do. So, I think we can then conclude from multiple studies that real ear aided measures give more audibility, whether you're talking about children or adults.